This is the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
Welcome to the Math Map Book Club, where every week Kirsty Gilpin and I discuss the Math Map and how to use it within the Classroom Conversations communities. Today is Wednesday, October 29th, 2025, which means we're more than midway through our academic calendar. So Kirsty, what are we going to be working on this week?
We are working this week on lesson 14, constructions. And while we are happy to talk about constructions and how to do them, if you brought those questions this week, we are, again, primarily talking about how this works at home with multiple ages of students and how we can emphasize those skills of learning. So if you are looking for detailed examination of the constructions themselves, either wait till the end and see if people ask those questions, or certainly go back and check out previous iterations of the book club where we perhaps did a little bit more detail on the construction content. As we do every week, we talk about flashcards. We had a great conversation this morning, a group of us, about different ways that we can use flashcards. And one of the questions that came up was, which deck should I use? Is there an order? Where should I be going? And the hard answer is that it's all grammar. We're not expecting you to understand any of it. You're just memorizing it. So really, you can pick any of them with any age student and just load the grammar. Realistically, we have a lot of options. And so if I was to pick an order with my youngest learners, I would probably emphasize the addition and multiplication facts and the notations. Next, I would probably mix in some of the fraction cards and then grow into the exponents, roots, and logarithms cards. Again, it doesn't have to be that way, and you can mix up all of the decks. And I know that that's hard because we're so used to being told exactly what to do, especially when it comes to mathematics, that the freedom to choose for yourself isn't always welcome, because it's nice when somebody says, pick these 4 flashcards and practice them. So I just wanted to encourage you that you can't go wrong. Right? That, we talk about these strategies for flashcards. One of those is choosing the flashcards by the lesson, right? Or by what you want to practice, customizing your practice deck by mixing them up. And I really want to encourage you that you can do that, and you really can't go wrong, because eventually you're going to need all of it. So specifically this week, our strategy is just fast facts. And if you want to memorize a lot of flashcards, this may be a strategy, a good way to go and explore some different decks, right? Because when you're doing fast facts, the goal is just to get through as many flashcards as you can. So you could set a timer and just say, we're just going to go through as many as we can. And if that means we get through 2 decks, hey, that's great. The idea is that with fast facts, there's no hints. There's no hemming and hawing. You either know it or you don't. If they know it, you drop off the cards that are correct, and the cards they didn't know go back in the pile, and you can keep going through. So you could have multiple decks. You could have 1 deck. You could have 10 cards with fast facts. But the big idea is no hints, and we can repeat those cards if they were missed the first time. Our cover this week, I think, I really enjoy this cover. I think that there's a lot to talk about as we look at our geometer here and talk about how geography and geometry are so tightly interwoven. As we look at our cover, our skills of learning that we want to emphasize in our book club this week, remember that at home you can pick any of these 15 skills And you can use 1, 2, 3, probably nobody's going to use all 15 in one conversation, but you can pick and choose depending on the flow of your family and the rhythm of your family's learning. You're going to pick some of these skills of learning. So if you're looking at definition, one way that you can do that is by having your students identify 3 words that they want to define, or 2 words, or 4 words. They could be words that they are familiar with, such as their domain name. They could be words that perhaps they're not familiar with, something that's from the quotation or the reflection. But by specifying a number, instead of just saying, hey, are there any words we should define, right? That leaves it kind of open-ended and it's easy to say no. But if we specify, find this many words, they have to go and look and specifically choose those 3. For comparison, let's think about comparing the quotation and the reflection. They were all chosen specifically for the lesson, so that suggests that there is some similarity between them, between the ideas in them, yet they are chosen for different purposes. So there's automatically going to be some things that you might find that are similar and some things that are different. And so that's a great way to compare, to practice that skill of comparison using the quotation and the reflection. You can discuss how the topic can be related to a different dimension. Right? So as we think of circumstance, again, circumstance often means, or I always understand circumstance as same place, but let me say that again, same time, but different place, right? If we are building this holistic idea of dimensionality, right? So I could have a point, but that point lives on a line, right? The circumstance is what's on that line that's around that point. And if that line is similarly on a plane, right? Then my idea of circumstance would be to say, well, what's happening around that point in the plane? What's happening around that line in the plane, right? And we can extend that. So circumstance is a great opportunity for thinking about dimension. And similarly, using the different dimensions is a great way to practice circumstance. Relationship, we often think of it as an order question, things happening in the same place but in a different time. It can also be where we think about cause and effect. So as I was thinking about that this week, I thought one way, especially if you have students who are perhaps in their 2nd, 3rd, or more years of the math map, you could say, well, what do you think you needed to know from previous lessons before you get to this one? If you've done constructions before, ask your students, what do you need to know? Well, I need to know about circles, and I need to know about segments, and I need to know about lines. I need to know how to use my tools. So what do I need to know before I start this lesson in order to be successful? That would be a great relationship question. And then as an authority or testimony question, I was thinking that a great way to talk about the art is say, well, how does that art testify about the content of the lesson? Right? Why was that art chosen? What might it tell us about constructions? And so there's a testify that's telling us about something. Does anybody have any questions or things they'd like to share about the cover and the exordium?
Yeah, Chris, I think you did a really good job reviewing this. I mean, how many times we've heard it, and you keep giving us different examples as you go through the 5. And also I want to let people know circumstance. I'm trying to eat my lunch. So I keep stopping and starting my screen, but I am listening intently. So when you were talking about the flashcards, and now about the cover, I just want to say that our children can only do so many things at one time well. And for someone who's just starting off on the math map, it's just to feel comfortable, if that's all you're doing is having these art conversations and doing the flashcards, maybe asking your student to read out of 1 or 2 pages of the book or trace 1 or 2 pages. That's an excellent beginning because you're introducing your child to an entire universe of mathematics, not just completing a credit.
That's a really great reminder
I
that
like these
we
examples too, just because I feel like I always need practice with these skills. And so I don't know, I was brainstorming while you were talking about how to use these specific things for the cover. I was thinking, well, you could do that same thing on the iPage, and you could do that same thing on, a lesson page, because like 3 words to define, I'm pretty sure I could go through one of those booklets and find 3 words I don't know and I need to define them. So it doesn't necessarily have to be. So I'm just thankful for the practice, because I feel like I still need practice in these skills. And a lot of the examples that you have, we can really do that with other pages too. So.
But that's really what it's about, right? As Lee pointed out, right? If we're just trying to check off, I got a credit, I did what I was supposed to do. If that's the goal for your homeschool, you don't really need the skills of learning, right? Because you're just going to check off what you did. But for those of us that are in classical conversations that have chosen this way of homeschooling, because we chose it because this is how we learn, right? These 15 skills of learning are not skills that Lee made up, right? Or that the math map team made up and we said, we're going to teach you this really weird way of thinking, right? These are how we work. This is classical because it is, right, transcends the ages. And it is, when we look at the Bible, it is supported by the ideas of how we learn as described in the Bible. So we think that we are encapsulating, right? That is our goal, is to give you some signposts or some guideposts for how to guide your children to recognize how they already learn and apply that to everything. And so that's why we keep practicing, because definition isn't unique to math. It's not unique to the cover, but it's a great skill for your students to have no matter what they're doing or where they are. And if you really want to be encouraged, I think that the best thing you can do is talk to people who have recently graduated students from classical conversations and ask them, how are they finding life, right? Whether they're in university and they come back and they go, oh, well, I was really, really prepared for my exam in rhetorical eloquence because I just used all the things I remembered from CC, right? So that was just this week what I heard from one of my children. My other child chose to go to the Marines and called and said, yes, well, guess what? I remembered my exordium and my arrangement, right? And then the other day he said, I was teaching somebody, and he goes, so I told them, well, here's a little bit about all of it, and then we're going to go in greater detail as we work through this. And he looked at me and he said, yes, I know, that's the math map, right? And so we see this from our recent graduates who maybe were not big fans of CC at the time, right? Not everybody is, and that's okay. I want to encourage you that sometimes we hear these really beautiful stories about amazing tutors and amazing moms and how their children just love learning and they have these rich conversations. And I want to encourage you, if that's not your home, that's okay, right? Because that was not my home, right? I was working with Lee on the math map, and so I was not that amazing mom that did all the cool things, because I know God needed me to step back and let my kids take some ownership, right? So I'm not sitting here going, oh wow. I'm saying God knew I needed to give my kids some space, and so he distracted me. They didn't have rich conversations. They sometimes had knockout, drag out fights, but they were still using what they were learning, right? It just wasn't beautiful. So they didn't maybe grow up going, oh, yes, we're just so amazing. There are those families out there, but there's a lot of us that don't have Norman Rockwell cover picture families. And I want you to be encouraged that they go off and then they come back and they go, wow, I really got a lot out of my classical education. And so I want you to be encouraged if your family looks perhaps a little bit more like mine, that this really does work.
My oldest child, he's a sophomore in college, and he was trying to figure out the next step in work for his life, whether or not to take like an internship or to continue where he's at. And so he literally wrote an Annie chart. And he does that quite often to try to figure out how, like, what decisions he wants to make. So, yay.
That's great. What's not so helpful is when your kids want something from you and they write the Annie chart and use all those skills to convince you that you're wrong and they're right, but still a good application. So also on our first day, after we talk about our cover, we always like to make sure that we don't shortchange knowing where we are, right? And so we are going to be in lesson 14, constructions, which is part of our 2D planar space. So don't skip over the math map. It really is valuable to help your students see how they are making progress through the curriculum and in building their math understanding. So our strategies for lesson pages, we've got a whole long list there, and I'm not going to read through all of them. I think next week, as we're looking at lesson 15, we're going to go back and we're going to kind of review these in a global way, and then we'll start the list over in lesson 16. But the idea that I had for you today, especially as we're looking ahead to next week being our Blue Book week, that your lesson pages, we can use our lesson pages and incrementally review toward our goals, right? And so if we have set our goals at the beginning of the year and we know what we're trying to work towards, we can be looking for things in the lesson pages that are going to be helping us work towards those goals. So if your goal is for your student to be able to read a math page, right? Maybe, right, as Lee said, just have your students read some of the pages. Don't worry about doing all of the exercises. If your goal is for your student to be able to sit and work for 20 minutes without getting up and dancing around or, right, doing all of those things. So maybe you've been gradually increasing your time each week towards your goal of 20 minutes. So maybe at the end of 20 minutes, I put my booklet away, right? So you sat for 20 minutes. And so I've been doing that. I'm not going to make you work beyond that. We're just going to do this because that's my goal, is for you to master yourself and be able to sit still for 20 minutes. So notice that has nothing to do with learning the math itself, right? But I'm using the math map, I'm using my math lesson in order to work towards those goals. It may be that I have some.
Kirsty, I want to add is that sometimes the goal is how do you manage a lot of information? And so you might just practice for a week using just the tops or putting a piece of paper over something that's too distracting, or doing the frame rather than the interior. That academic management is definitely something that young people need to practice.
Yeah, absolutely. So, and that's the point, right? I think is that we can have a lot of different goals, and they may be mathematical. It might be, I really want my students to become fluent in being able to identify the symbols. And so what we do is we just go and look for all the mathematical symbols in the booklet. Or maybe I want them to improve their calculation. So I'm going to go through the booklets and find all the calculations. Maybe I want to make sure that they're learning to attend to the instructions. And so maybe every week, the first thing I do is I make them go through and highlight all of the instructions. So if I know what my goals are for my students, whether they're mathematical or academic, I can use my lesson pages to work towards those goals. Right. And so we're not trying to just get to Blue Book Week and say, let's review all of this, but we've been looking at how we're working towards those goals as we progress throughout the semester.
Other examples you just gave, Kirsty, is why for decades, experienced homeschoolers have said, look, I can teach my children everything they need to know out of a cookbook or out of a hymnal or out of the newspaper, because we know that it's the strategy of using the material and the perseverance and the practice in building the vocabulary around whatever the material is sharing with them. And then, so if they have that general skill, they can do better at math than they would have otherwise, because they're going to do better at any subject if they just practice those study skills.
So looking at our lesson pages, I'm just going to talk about the structure because there are going to be very clear delineations, I think, this week that exist each week, but you're going to really clearly see it this week because the tools are going to be different for each of our 4-page sets. So our page 1 set, which is page 1, page 5, page 9, and page 13, all have to do with patty paper constructions. So they're all about using a piece of patty paper or multiple pieces of patty paper in order to explore some geometric truths. For our littlest learners, just learning how to fold a piece of patty paper is a skill in and of itself, right? Taking a piece of paper and folding it in half one way, folding it in half another way, folding it in half diagonally, or if we had a circle on the paper, folding the circle in half instead of the paper in half, right? So there's although we're guiding you through building up towards doing the complete constructions, we really want to encourage you that there's a lot of motor skills that can be practiced in lesson 14. And to give your children the opportunity to rest in practicing those, because they will get the opportunity to explore the math, right? They're going to see this every year. And so don't be afraid to wait and just say, we're just going to play with folding patty paper. We're going to play with using a compass. We're going to play with drawing a straight line using a ruler. And to do that for several years.
Can you define those for us, for people that are coming on for the first time? Patty paper, compass, and your double edge, straight edge?
Sure. So our patty paper is literally the waxed paper that goes between the patties, hamburger patties. And now you can buy it in a box for about $9 from Amazon for 1,000 sheets. Depending on the quality, I would read the reviews because if you get one that's square, I think that's a little bit easier. And sometimes they are cut not square, but I try to get the ones that are cut square. They're a little bit thicker than a roll of waxed paper, but they have that same quality that when you fold it and unfold it, you can actually see where that fold was because that wax kind of goes white, right, when you fold it. So you can see your folds easily on patty paper. You can also use it as a tracing sheet because you can trace, you can see through it. It's a little bit translucent. So that's patty paper. A compass is, as you see there, that's a divider style compass. It is anything that we can use to draw a circle. A compass can be a divider style. It could be a pen and a piece of string with a pencil on it, right? It's anything that's going to measure a constant distance and have a pivot point. So there's a lot of different styles of compass out there. One of the ones that we've enjoyed learning how to use at the Math Map offices is a safety style compass. They have different names, but they're a little bit easier sometimes for younger fingers because there's a spot that you can hold with a finger while you spin something else around it. And so it's a little bit easier than mastering keeping the pressure on both points of a divider style compass. So let's talk about, I'm just going to stop there talking about the compass and talk about our compass and our double-edged straight edge when we get to those pages. So let's come back to our patty paper. Any questions about patty paper or what's happening on this page 1 set? Okay. So on day 2, that is the day that we encourage you to take a look at that invention page. And I know I say this every week, but I think it's because we all need to be reminded, right, that it is called the invention page because the goal is to practice the common topics of invention, right? There is helpful math arranged on this page. It is a helpful math page, but the purpose of the page is not to learn the math. It is to practice the common topics of invention. And just as Lee reminded us, we don't want to overwhelm our students. So the goal is not to practice all 5 common topics every week, right? But to pick 1 or 2 that you're going to just take a few minutes, right? 2, 3, maybe 5 minutes at the most to look at this page and practice that common topic. So that's why every week we just talk about 1 common topic, because we really want to encourage you to just talk about 1 common topic, not all 5 at once. So again, circumstance, same time, different place is always how I learned it. And so we can think about that, as I mentioned earlier, when we talk about dimensions, we can ask the question, well, what would be hidden if there were fewer dimensions? So if I had something that was drawn on a piece of patty paper, well, if I fold it, right, and I get that line, the rest of whatever's not on that line disappears, right? So what's left on that line? Or if I had something that was on a, right, just defined on a line, but then I suddenly said, okay, well, let's expand that to the plane. What might be revealed if there were more dimensions? Right? That can be done well using a tissue box, and we're going to talk about that in a couple of weeks. Right? But I can say, okay, well, here's my plane, right? That's all I have is my plane. But what if I had 3 dimensions? Now all of a sudden I see, right, not just a plane, but I'm seeing a whole different aspect of a box, right? Here you might think I just had a piece of paper, but once I hold it so you can see all of those dimensions, the rest of that box is revealed. So asking your students those questions. Now these, admittedly, right, these questions are probably some that are for more experienced students, right? And so we've talked about circumstance questions that are perhaps more accessible to less experienced students. Thinking about fewer dimensions and more dimensions. That might be a student who's more experienced. We can also ask a circumstance question about domains, right? And a question we might ask our students, well, what's more familiar if we were working in a narrower domain, right? So our concept perhaps of addition might be the same idea, right? But maybe 1/2 plus 9/16 feels kind of overwhelming. But if I said, what's 1 plus 9? Oh, that's more familiar. So we're still thinking about addition, right? So asking our students, well, what did a narrower domain help us, right? So thinking about different domains may be another way of considering circumstance. On page 2, 6, 10, and 14, you'll notice that our constructions are the double edge, straight edge constructions. The double edge straight edge is anything that has 1, 2 edges that are parallel. So notice I'm holding up a piece of paper. This would be challenging to use because it's so wide compared to its length, but I could use a piece of paper as a double-edged straight edge. I could use a piece of wood, a 2x4, as a double-edged straight edge. It doesn't have to be a ruler. And the reason why we really differentiate between that is because on a ruler, we're tempted to measure, right? Whereas with a double-edged straight edge, the point is that you're not measuring, right? So I can use a ruler as a double-edged straight edge. We just want to really encourage our students that we don't care about those markings. We're not here to measure. We're just interested in having two edges, double-edged, two edges that are straight and parallel. I think these are interesting because it's probably the simplest of our construction tools to use. Right? It's simpler to use a double-edged, right? I don't have to have a compass if I'm out in the wild somewhere, right? As I said, a 2x4, right? I could like pick up a 2x4 or even like a branch that's like kind of parallel, right? To just pick that up and do constructions, right? So they were used a lot for battlefield constructions historically. So very simple tool that still help us to be very, very precise. So when we're talking about mathematical constructions, we're always talking about exactness and preciseness. That is our goal. We're not going to get there with our integer students, right? But our goal eventually, by the time our students are nearing the end of their journey with us in our homeschool, is that they should be developing the skill of being patient, of being exact, of being precise, right? Of being careful. And that's why we keep emphasizing, take the time to just practice using the tools well, because they'll learn how to put the pieces together as time goes on. Right. But to construct well, you have to be careful and precise. So this unit is really a lot about governing ourselves and our tools as much as it is about practicing the mathematical concepts. So that's the double-edged straight edge. Any
Thank you about
questions?
that. Yeah, the double-edged straight edge. So so I'm very often using, because there's so many books around me, I use books for double-edged straight edge, and I see my son in construction using the 2x4 like you talked about. You were on a ship and navigating. Was there something that you would just grab, or did you always have really precise devices?
We used interesting. I was watching something the other day and I had forgotten. I'm trying to remember what it was called, but it was like something that would kind of like do this. And so it was kind of like a double-edged straight edge, but you could actually make it like go farther because you could move it. And then I had a rolling weames, which is a double-edged straight edge, but would roll. That was always one of my favorite tools. But we did use a lot of straight edges, and parallel lines were very important in navigation. All right.
I have a
So
question, Christy,
yeah,
on the fractions and what's the pink one?
integers.
Integers. On the right-hand side, it says perpendicular through a point on a line. Where is the perpendicular line?
It's not there.
Okay.
Because these are just steps towards what they're doing. So,
Okay. So practicing what they would do in like the monomial shows.
yes.
Okay.
So you'll see if you look on monomials here, what they're doing is sort of this first step here. And so what they're doing, if you look the left side to the right side, the right side is about drawing a perpendicular bisector. So the first step on the right-hand side is actually creating this segment AB, where P is the midpoint, because then I can create the perpendicular bisector of that segment, just like I did on the left-hand side. And
Got
so that's what they're just stepping through towards that, eventually being able to do that.
The
That
other
was a
thing
good
is notice
question.
the sizes, Andy. The through rationals, it's the same size as a real ruler. You know, it's an average size, right? Rulers can be slightly different, so the student can actually put it right on the paper. Versus once they hit reels and on their demonstrations, and so they'd have to do it off paper. A lot of the work.
Brilliant. Thank you.
So on our third day, we're going to look at our Memoria and arrangement page, which again takes the idea that we have content, this grammar, but it's going to arrange it and to help put it into context. We're really going to look at practicing our core habits of Memoria, and this week is expressing. So when we think of expressing, we can think of movement and we can think of models. As we look at this particular I cubed page, right, I think there's a lot here that you could talk about demonstrating with hand motions, right? So show me a line, show me a straight angle, what's an obtuse angle, what's a right angle, what's an acute angle, right? So I could use my hand motions, show me an intersection, show me parallel lines, right? So going through and using hand motions. When I look at the entirety of the lesson, right? We're building, we're constructing models. So this entire lesson is about expressing, but we could, with our younger students, just give them this page and some spaghetti right, just those things like that, some spaghetti and marshmallows, right? And say, okay, I want you to go build all of these things out of spaghetti and marshmallows. So that's a way that we can express, is either using movement or models in order to demonstrate these ideas. So that's a great way we can interact with our Memoria and arrangement page.
That sounds so fun. I can't wait to do that. Like, I literally want to go get a box of spaghetti and little baby marshmallows and do it like right now.
What would be fun is if you like cooked your spaghetti and then you could like make all your little shapes, but not the lines, but maybe the triangles. Compare. There would be a great comparison, right? What's better, cooked spaghetti and especially if you got it where it was sticky, so it would stick and go where you wanted it to go.
It makes me think about Elf, because you know how he had spaghetti and then chocolate syrup and marshmallows and put all the yucky stuff on top of his spaghetti. He made it sweet spaghetti.
Will you let us know how that tastes, Babs?
I don't know that I'll eat it. I'll just play with it.
So page 3, which that set, so that's gonna be our 3, 7, 11, and 15. Those constructions are all going to be a compass and a straight edge. So for many of us, a compass and straight edge construction might feel like the most familiar, even though it may also be one of the more challenging with our when we think about our motor skills. The compass and straight edge constructions are probably our most challenging, because using, again, that compass is something that's just going to take a lot of practice, no matter what kind of compass you're using, because you have to hold your pivot point steady and do something else with that other part that's swinging around. So you're doing two different actions at once. So we want to be really patient with our kids, help them to be patient with themselves as we learn how to use these tools. Right? The same with a straight edge, right? Holding a straight edge and drawing along it. My left hand and my right hand are doing two different things. So again, be patient with our students when we're trying to do these constructions, because they really are challenging, right, for all of us, but especially for younger students. Again, as you look here, you're going to see we're not doing all of the constructions. We're building towards being able to do these constructions with the compass and the straight edge. And so we're practicing. We're really emphasizing practicing. Any questions about the compass and straight edge constructions? Yes, Lee.
Yeah, I would say, so if you read the instructions, the little guys aren't expected to use the tools at all. They can, but it just says trace. But then when you get to the decimal fraction rationals, notice the instruction says trace, but try the tools. And then, of course, for reals, complex, and monomials, we are asking them, please try to do this last blank spot with the proper tools, so that then when we hit binomials on in the more of the high school years, they are prepared to do the entire construction.
One of the things that you can do with your children with this particular, right, the compass and the straight edge, is talk about why the compass is so useful, right? And go back and review the definition of a circle, that it's a set of points equidistant from a given point, the center, right? And so we use it to measure distances, because anywhere on that arc from my point to that arc is going to be the same distance. And so that's why the compass, that's how the compass works, right? By using that property of circles and encouraging our students to recognize that.
I have a question about the compass. I just thought about this because I didn't realize there were two different kinds of scissors out there for like right-handed and left-handed until I had a kid in my class who was left-handed and he needed a different kind of scissors. Does it matter if you're right-handed or left-handed when you use the compass?
I don't think so. I think they should be an ambidextrous tool, but obviously how you use it may be maybe kind of mirrored, right? So I know I tend to turn clockwise if I'm using a traditional compass, and I wonder if a left-handed student would turn counterclockwise.
So as a testimony from a left-handed person, I struggle with compasses.
Oh, good to know. Because I don't remember if that student had trouble with the compass. I don't remember it being an issue, but I remember having to go get different kinds of scissors because I didn't realize he needed a different kind. So I was just thinking about the compass, but I think I just need to pay attention, I guess, to how they use it.
Yeah, the safety one is easier for me just because I don't know if it seems like holding the pivot one, like with your right hand, it feels awkward, but with the left hand, it doesn't draw straight either. So the safety ones are easier for me to use, but I'm on the struggle bus. It's okay though.
I like the safety ones anyway. I don't really like the kinds that turn. I mean, I like the safety ones. I just think they're a lot easier to use.
So on your fourth day at home, this is where we talk about using careful calculations and going back again to this idea, right? We're looking towards next week being our Blue Book week. So this idea of not leaving everything to the last minute to review, but how do we build a cumulative review? And something that you can do with the careful calculations page is perhaps highlight a couple of model problems from each week. So if you hang on to your careful calculations pages and you highlighted, maybe it was a problem that you discussed with your child, one that they felt really confident about, or perhaps one that they needed some extra practice on. Maybe highlight a couple of exercises from each of your careful calculations. You can use those as a model to create a new exercise, and then pick a few of those to practice each week or as part of a cumulative assessment. So I know we're only talking about this now on week 14, but let's say next semester you decide you want to do this. So perhaps on lesson 16, you pick out a couple of problems that you're going to add to your students' careful calculation in week 17. Right? And then maybe you carry one of those and one from week 17 to lesson 18. And then maybe you're not adding every week, so you don't end up with an extra 15 exercises, right, on week 30, but you start picking and choosing, kind of like we did with reviewing flashcards. So you sort of say, okay, well, I did 16 for a couple of weeks. I'm going to save that one and come back and look at those 16 questions on week 24. And now we're going to look at 17 and 18, right? So there's different ways you could do that. But again, you can build, using these as model problems, build your own cumulative review for your student towards that cumulative assessment when you get to those weeks where you want to do that. I think most students are going to really enjoy the 4 set, page 4, 8, 12, and 16. The goal is just to practice with the tools, but this time creating art. And so they're going to look at line art, daisy wheels, circles, right? Circles and lines. Notice the pattern here. We're looking at lots of circles and lines. There's a lot of tracing, a lot of coloring. So these 4 pages are here. One strategy that you might use for lesson 14 is to flip your book and start with page 4, 8, 12, and 16, right? So I practice first and then I go look at my constructions. So it may be a pre-practice before I try to do the other constructions, or if I have students who maybe need a little encouragement, maybe it becomes my reward. So you can look at it as bookending your day in those ways. Don't forget that there's lots of avenues for support. Lee is on with us this week. So just thanks again, Lee, for your commitment to hosting these book clubs. Thanks for your commitment to having a curriculum assistant who is dedicated to answering people's questions. This is a resource that nobody else provides, and it means so much to be a part of a company that prioritizes our customers and supporting them with all of these different methods of support. And so whether you're here live or watching a recording or sharing it with a friend, please take advantage, right? We keep hearing people that are like, well, I was kind of afraid to come to the help desk because I didn't want to look stupid, or I didn't think I was smart enough to come to the book club. There's no judgment, right? The Bible says that God wants us, if we lack wisdom, to ask, and he'll give it to us generously without criticizing, right? So if he is willing to hand out help without criticism, without judgment, so are we, right? So there's no question that we're going to roll our eyes at or not want to answer. We really, if you have questions, if you're looking for wisdom related to the math map, we really want you to come and ask us here. So just a reminder, next week we'll be talking about lesson 15. Then we're going to look ahead to next semester with lessons 16 and 17. We will not meet on the Wednesday before Thanksgiving. We're going to have 3 weeks in December that are very open for your questions and answers. And then we won't meet on Christmas Eve or New Year's Eve. Does anybody have any questions about support or when we're meeting? We did have somebody send in a question this week, and the question that they sent in was, I can't remember if their question was from monomials or from complex. So we put both on here. This is page, Babs, do you remember what page this is? It's lesson 9.
No, but I can look it up.
And I think it might be page 4. So I should have made that. I think it's lesson 9, page 4. So on the left-hand side, as you can see, more has been done for you than on the right-hand side, complex versus monomials. These are, I think, particularly challenging when we're talking about absolute values. So I just want to take a minute and talk about how we work with inequalities, and then specifically with our absolute values. So I always say that we're going to go step by step. That my first step is going to be question mark or equals. If it's less than or greater than, and I just wrote those backwards to how I said that. So if it's greater than or less than, we use a dashed line. If it's greater than or equal to, less than or equal to, we use a solid line. So that's the first thing that we're going to do. The next thing that I'm going to do is I'm going to think about the related equation. The reason why is I think that our students, if they don't have to worry about the less than or greater than part, right, it's just simpler. So just look at the related equation. So in the case here, I'd be looking at y equals the absolute value of x plus 3 plus 2. All right, so I'm going to look at the related equation and I'm going to graph it. For these, making a table of values is probably going to be your best bet. And so we can look at where x is 0, and in this case, y would be 5. I might look here what happens if I had the opposite. So at -3, y is 2. I might think about where, is there a case where y is 0? In this case, right, this is a great example for asking your students to stop and think, right? If the absolute value of a number is always positive, and then I'm adding 2, right? Is it ever going to be 0? No, it's never going to be 0. So trying to figure out where y equals 0 isn't going to work, right? I might say, okay, well, what happens at like -6, right? I saw where -3, I saw 0, -3. What if I go -3 the other way? Is my y value still going to go down? Well, I see here that my y value is -3, sorry, -6, 3, this is 5, not 2. There we go. So now I might go, okay, well, let me see if I have enough points. And so I have my 0, 5. I don't have far enough over here, but it would be up here. I have -3, 2. I might go, well, if I draw these two lines here, oh, I don't need these parts anymore because they intersected there. So I've now got my inequality. Right? Graphing the inequality is probably the hardest part. It was or equals, so it's a straight line. Now, step 3 is to shade. I realized after talking to somebody fairly recently that one of the things that we have to understand when we think about this is that that equation, right? When we look at this equation, where it is up and down is its y value. So if I want where y is greater than that line, right? At this line, at this particular x, right here, my y values are going to be less than the line. Here, they're greater than the line, right? If I come up here, right, you can't see it, but these are all less than. Once here, I get greater than, right? I'm less than, oh, now I'm greater than. And so that's why I'm going to shade everything that's inside, because that's where my y values are greater than the y values that are on the line. So again, it's greater than, so it's going to be above the line. When we look at the next one, let me turn back to my pen. All right. So I now have the absolute value of y minus 3 is less than x. So my question 1, it's less than, so it's a dashed line. Now I'm going to look at my related equation. The absolute value of y minus 3 is less than x. I'm going to reverse this and write this as x is greater than the absolute value of y minus 3. Because it solved for x, and I cannot easily solve for y when I'm doing absolute value, I'm going to rewrite this so I'm thinking about where's my x value, right? but I'm thinking about my equation. So x equals the absolute value of y minus 3. And again, I'm going to use a table of values, but this time I'm going to look at my y's. So I might say, okay, well, when y is 0, x is 3. When y is 3, x is 0. I've gone 3. Let's try going up to 6. At 6, x is 3. So I've got 2 points, right? I've got 3 points. So I've got 0, 3. I have, right, here's my 0, 3. I have my 3, 0. Sorry, that's the one I did. My 3, 0, my 0, 3, because they're written backwards, and my 3, 6. And again, I see here that I have, right, my absolute value. As our students become more familiar with absolute value graphs, they're going to start to go, oh, well, y equals absolute value is going to be an upward V. Y equals negative absolute value of x is going to be a downward V. X equals the absolute value of y is going to be a side V or a negative side V. Okay, so they're going to get that in time, but right now we're going to maybe need to help them to develop that understanding of absolute value by helping them to develop a table of points, or just go ahead and let them look at the solutions in order to see where that is. And then our third step again is to shade. And this is really why I wanted to think about this in terms of x, because I can't say, well, what's y's relationship to x? That's not the relationship I've been given, right? I've been given the relationship of the absolute value of y. So by writing this in terms of x, I'm just going to get to my highlighter again, right? In terms of my values of x, I want to know where is x greater than, right? So x is greater than, where's my x value bigger? Well, it's going to be bigger everywhere to the right, right? I'm just looking where my x values are greater. But I needed to rewrite that in order to be able to shade that. Right. So we see the same thing. I'm not going to do all 4 problems in monomials because hopefully you see the process that we're following here. But let's go ahead and work through. Let's take a look at this one here because it's not done for us. So step 1, it's less than, it's a dashed line. Step 2, right, let's rewrite it as x is greater than the absolute value of y minus 5. And then we're going to graph x equals y minus 5. So here's my x and my y. So I'm going to start with where y is 0, x is 5. If y was 5, x is 0. If y was 10, x would be 5. And so we see, again, we have the same sideways triangle or sideways angle here. So at 5, 0, sorry, this one, 1, 2, 3, 4, 5, 0, 0, 5, and then I'd be way up here. So I'm only going to actually have half of my absolute value graph, right? The other half is going to be up here off of my graph. And then step 3, I'm going to shade. And again, when I'm shading, I'm going to use my x greater than, right? X greater than, so that's everything to the right. So they're challenging, right? I want to be really honest that these absolute value graphs are challenging. They are going to get better in time as we become more familiar with them. But the shading part of it, right? If it's above, right? If it's greater than, it's going to be above. If it's less than, it's going to be below. So just thinking about that with your students, I think that there's a lot, a lot to think about that, right? So if it's greater than, right, y is greater than, where does that make sense? Well, my y is my vertical, so it makes sense that it's above. Y is less than, where does it make sense if vertically it's going to be below? If it's x greater than, where does it make sense, right? Where are my x values greater? To the right. If it's x is less than, my smaller x values are going to be to the left. So hopefully, we always appreciate people who send in questions and plan to watch the book club recording. So we really want you to feel encouraged that you can do that. And hopefully this was helpful and answered that question. Did anybody else bring any questions that they'd like to talk about today?
I have some.
Okay.
From Monomials, book 11, page 1. I think
All
my
right.
daughter was getting into her head, and just like thinking through like, oh, if it's this hard right now, is it ever going to get harder? I have not seen this kind of math before, so I couldn't answer her question, but her question was if she was just given the graph, the picture of the graph, and y equals -3, and you have the point -1, comma -1, would you still be able to fill out the examine part of it? Like, what's your 8? What's your k? Like all that information below.
All right. So Babs is working her magic. So as soon as it pops up on the screen here, we're going to look at this. Okay. So right page. So can you repeat the question now that I can see what we have here?
Right. So she was saying if you're ever just given the three graphs on the top, the one sloping this way, the one straight across, and the one sloping up, would you ever be asked to fill out the f of x equals the a open parentheses base exponent x
So
minus h? Would you, if you're just given the graph and the point and the y equals, could you fill
yes,
that out without knowing anything else?
yes, you can take a graph and write the equation. I don't know, that may be something that we encourage in like the transcendentals year of the math map. It is not something that we have in the current lesson booklet plan, but I would say to her, okay, well, what would you do, right? This is a really great opportunity to have that dialectic conversation about, well, what do you need to know? Right? Well, the first thing you need to know is what parent graph do you have? Now, if we were looking at the middle one, we've written it here as an exponential graph, but we could certainly have written it as a constant graph, right? There's a lot of ways that we could have written that. We don't really know. But here on the either side, there we might go, okay, well, we recognize those as exponential graphs. So I know it's going to be some, right, y equals some e to the x maybe. I don't know. Or some, let me change that to b to some x. And if I looked at the left-hand side, not this year, right? But if I've done this a lot, I'm probably going to go, well, I know that that base, right? If looking at this one, I know it's going to be something. I'm going to guess that it could be maybe 1/2, right? I might not pick 1/3 without finding points, right? Which sometimes I might find points that I can go, oh, I can figure this out. But it's hard to work backwards because I could find a lot of ways to work forwards. So let's just say it was 1/2, and then I might say, well, is it going through the points that I expect it to go through, right? Did it go through the point 1, 1? Well, it didn't go through the 0.11. So how did it move? So then maybe that's where I go, okay, well, it's gone back 2 and down 1, right? So I might guess at, this is my X, sorry. Right, -1. I might guess that it's something like that, which isn't what it is, but I might be getting close. Or I might, right? And so then I might go, well, wait a minute. My asymptote's at -3, so this wasn't right. This needs to be -3. And I might keep refining it. So there's ways that I can work backwards, but I'm not going to lie, it's not easy to do. Right? There are ways, but what she should be able to do is look at a graph. And in this case, she should be able to go, well, I know it's not a polynomial, right? It's not a polynomial. If I have a horizontal asymptote, it's not a polynomial. If it has a horizontal asymptote, it's got to be either a radical function, a rational function, or like an exponential function. So right away, as I gain familiarity, I'm asking these questions. Right? Is it decreasing or is it increasing? Well, it's decreasing. So it could be a base less than 1. It could be something else. So I start asking these questions and comparing to what I know to start honing in. So I may not ever get the perfect equation that's there, especially as a high school student, but I should be able to start analyzing it and getting some key characteristics of it and getting close to what that equation was.
That's awesome. Thank you.
You're welcome. Do you
And
have other
then
questions?
I do. The next question would be like, so like for that graph that's on the left, is there an asymptote that also goes like vertical, or is it just the horizontal line? Because both
just
don't approach like a line that they would never cross.
right. So it's just the horizontal asymptote for the exponential function. So it might, because it's getting big fast, we might not ever graph it, right? We would need a really, really big piece of graph paper to graph x equals -15, for example, or x equals -20, because it grows so fast, but it will eventually get there.
Okay.
So yeah, it's just the horizontal asymptote for the exponential. But notice when we look at its reflection, the logarithm ends up with the vertical asymptote and no horizontal asymptote.
Yeah, I think that's why she had a question about whether it's always just going to be horizontal, or so only if it's a the inverse then. So could you say like f of -x then?
So, well, and again, this is the exponential function, which I can spell, has a horizontal asymptote. The logarithmic function has a vertical asymptote. And what you're looking at on this page is that logarithmic function is the inverse of the exponential function. And we write that with the little -1. That's the inverse function.
Okay.
Now, when you get to looking at the rational functions, those are functions that can have both a horizontal and a vertical. So there are functions that do have both horizontal and vertical asymptotes, but this particular exercise, the exponential just has the horizontal and the logarithmic just has the vertical.
Awesome.
Andy, with the kind of questions she's asking, I would suggest you look at the chart where it has all the possible cases and just like trace them or copy them and write the formulas that are near them. She's asking smart enough questions that those summaries might help her see patterns that we haven't put into the curriculum because they're just difficult.
Awesome. Thank you. And And I have one more question.
Okay.
So her question was like on page 2, you're identifying what kind of graph it is. And she wrote down line, but the answer key had linear. I didn't know if there was like a difference between line and linear, like labeling what kind of function it
Just
is.
a line. A line is more of a noun, and linear is more of an adjective. So if I
Okay.
said it's a linear function, I'm just using that as an adjective. But line would be fine. I would say that
Okay.
she knows what she's talking about if she wrote line.
Right. And that's what I told her. I was like, line is fine because that is a line.
Yep. Yeah,
Okay.
we're just using the adjectival form there to describe the function.
Perfect.
I think somebody else asked that question, and I think it's because maybe on the page or the chart it says line and not linear.
Yeah, we
'Cause I
had it
feel like
inconsistent at one point, and so for the latest edition, they're all cleaned up to linear. Because
okay,
I mean, I even had line here on this page at one time. So it was just
okay,
after everything was written, the charts, the page, and the lesson. It's a lot easier than to go through and make everything more matchy.
yeah.
Awesome. Thank you.
You're welcome. Well, I'm glad you brought your questions. And Lord, better, I'm glad your daughter sent her questions.
Yeah, she's full of them for sure.
That's good.
I
Well,
love it
thanks.
because she's old enough that I can be like, I don't know, find it. Look at your charts. What are you defining here?
That's good. And I think it's good to model for our kids that we don't always have the answers, because that way they don't always have to have the answers. They're not trying to live up to an unrealistic expectation of perfection.
Yeah, there's a lot of T-shirts out there, men wear, that say, "I don't need Google, I have my wife," kind of sentiment, which shows that we're all very too eager to help.
Well, thanks for joining us. I hope it's been helpful, and we will look forward to joining together next week. It'll be a little bit different next week because we're going to be looking at assessment, and so thinking through how can we assess as a family, right? There's a place for individual assessment, but as we're thinking through what does the math map look like at home, what are some ways that we can assess as a family, right, in this idea of working together, what does assessment look like? So hopefully people will bring their ideas.
Have a good week.
Thank you. See you next week.